Stanford University.
Okay, well, welcome to Lecture 12 of Stanford CS 193P, winter of 2015. Today we're going to talk about a different kind of animation than we talked about last week, which is physics-based. Dynamic animation is called, and then I'm going to do a big demo of that, which is called Drop It. First of all, let me say that our topic this week is dynamic animation. So it's a different kind of animation than we saw last week. It's a physics-based thing. Now, we're going to have some fun with it, this physics-based thing, and you're going to write a game with it. But I'm not sure you would really use it for that. It's more for things like this. You see how when I slide this up, it kind of bounces a little and wiggles? See? It doesn't just kind of solid go up and stop. It kind of bounces off the top. Basically what's happening there is that there's gravity pointing up, okay? And then there's a little bit of elasticity, and that view is just being allowed to fall up and bounce off the bottom, okay? And that's what we're going to learn how to do today, is have gravity and bouncing and all this kind of physics behavior. But instead of just doing something, boring like this, we're going to make a game out of it. And the game we're going to make is Breakout, or Brickout, sometimes people call it. And the point is to learn all the APIs of this physics-based dynamic engine, but to have some fun along the way. So I've actually made the requirements for the game itself be pretty light, okay? It just basically has to do the basics of the game, and then giving you a lot of room to maneuver on kind of the fun features of the game. So dynamic animation is different than the animation we talked about last week. Last week we were talking about taking certain view properties and animating them over time, or perhaps animating an entire change to a view, like a flipping over a card by flipping the whole view over, okay, or cross-dissolving the entire view. This is more where we're going to have our views and we're going to have them moving around on screen, maybe running up against other things and bouncing a little bit, that kind of stuff. The way you make this stuff work, okay, it's a multi-step process. The first thing is you're going to need a UI dynamic animator. That's the class that really drives the whole thing. So you need one of those, and you'll only have one for any animation that's going on. You can have multiple UI dynamic animators if you had, for example, another view doing some animation at the same time. But within your own view, you're probably just going to have this one animator. So you're going to create this animator. Then you're going to add dynamic behaviors to it. So behaviors are like gravity and collision and things attached to each other. It's how the things inside are going to behave, okay? And these are basically physics-based descriptions of how they're going to behave. And then, of course, there's the things that are going to be animated, which, for our purposes, are always going to be UI views, okay? These UI views, dynamic items, they are going to be affected by the gravity and the collisions and all those things, okay? And that's it. Just create the dynamic animator, create the behaviors you want and configure them, add the items to the behaviors, bam, it'll just start automatically animating. And if you remove an item from a behavior, it'll stop animating, okay? Simple as that. So let's look at these steps. The first step is you need to create a UI dynamic animator. And the dynamic animators we're going to use, I'm only going to talk about ones that animate views. You can actually use an animator to animate arbitrary things, okay? Not even graphical things. But we're only going to talk about animating views, okay? So when we create a dynamic animator that animates views, we have to specify the top level UI view, the view at the top of the view hierarchy where animations are occurring in. Now, animations can occur anywhere deep down that view hierarchy you want, but we have to specify the top level view. So in other words, any view that this dynamic animator is going to animate has to be a subview or a subview of a subview of a subview of this reference view. Okay? So this is the only argument you have to provide when you create a dynamic animator. Then you create these behaviors. The behaviors are these concrete subclasses of UI dynamic behavior. And so there's like UI gravity behavior. You just say UI gravity behavior. It's init, takes no arguments. And then collision behavior. And I'm going to talk about all these behaviors you can do. And you just add them with the method add behavior to your animator. Simple as that. And then you add the dynamic items, which are going to be UI views. Okay, dynamic items are really just a protocol. I'm going to talk about it in a second, but UI view implements that protocol. But you just add these items using the method add item on UI dynamic behavior. So you see how I'm adding the items to the behavior. So you don't add the items to the animator, you add the items to the behavior, you add the behaviors to the animator. Okay? So in this case up here, item 1 I added it to gravity and collider. So item 1 is going to be affected by the gravity, and it's also going to collide with whatever the collider sets up. Item 2 is affected by the gravity, but it will not collide with whatever's in the collider. It also won't collide with item 1. They would pass right through each other because it's not part of the collider. Okay? So if you want things to interact with each other, they have to both be part of the same behavior. Okay, that protocol I was talking about, UI dynamic item, that UI view implements, it just has 3 methods in it, or 3 properties actually. Bounds, this is read-only. So that means the animator cannot animate the size of something, okay, because the bounds part of the protocol is read-only. So the 2 animatable properties are the center, so that's the position of the thing. So you can see animators moving things all over the place. That's most of what they do. And then also a transform, which is an affine transform. Now notice that UI view already had all 3 of these properties, so it didn't even have to do anything to implement this protocol. That affine transform, by the way, is only used for rotation. So basically the animator can rotate the view or it can position it. That's the thing that the animator can do. Okay? Now, if you change the center or the transform, like you change the frame or the center of the view to move it, and the animator has a hold of it, you've got to tell the animator you did that by calling update item using current state. And you just pass the view, okay? And so the animator can say, oh, that thing moved, and it'll update its internal state to start from wherever that thing is. Does that make sense? Obviously, if you and the animator are fighting over who's positioning a view, you have to at least communicate, and this is how you do it. Okay? Simple enough. All right, so let's talk about some of these behaviors, the concrete behaviors. So gravity is very simple behavior. It just has an angle, so you can have the gravity be going up the screen or down the screen or to the left or to the right or any angle you want. And it has a magnitude. Okay? So the magnitude is in a scale where 1.0 is 1,000 points per second per second. Okay? You all know that gravity is an acceleration. Right? The acceleration due to gravity on Earth is 9.8 meters per second squared, and the acceleration due to gravity in these behaviors is 1,000 points per second squared. Okay? There's also, you can also set this as a vector, but angle and magnitude are probably the easiest way to understand this. So you just set this gravity. Now any item you add will start accelerating in that direction. The instant you add it, it's going to start accelerating in that direction, just like gravity, we're pulling on it. Okay? Then there's attachment behaviors. So attachments, you can attach 2 items, or you can attach an item to an anchor point. Okay? Now, that item's still going to be affected by all the other behaviors like gravity. So if I attached a view to an anchor point like this, and there was gravity on the view, it would swing down like this and stop, okay, if there was gravity down, right? Because the gravity would be pulling it down, but the attachment would be holding on to it. Does that make sense? So the attachment basically attaches things, but it's like a bar that's attached. That bar could be springy also. So if it was a springy bar attachment, then the gravity would pull it down and it would spring like this. Okay? So you can get a little spring in. You can control the dampening and all that as well. You can also control the distance between those 2 things. By the way, that distance is settable while it's animating. So this thing might be pulling down and you might be changing the length and it might swing way down and then you might pull it back up. So you can control all this stuff. All these things like that. Even the anchor point can move while it's animating. Okay? And we're going to actually do that in the demo. So it's incredibly flexible what you can do when you can change the attributes of these behaviors on the fly while things are happening, okay, with gestures or whatever. Collision behavior is an awesome behavior. You're going to use that very often. It can basically control collisions between items, and also between items and a boundary. And you can set up as many boundaries as you want. So for your assignment 5, where you're going to be doing this breakout game, you're probably going to want to use boundaries for all your bricks. Okay, you're not going to, they'll be UI views because you got to draw them, but you won't be having those UI views participate in the collisions because then bricks would start going flying into each other all over the place. You just want them to kind of be fixed boundaries that when the ball hits them, then that view animates itself disappearing. Okay? So the way you set these boundaries, there's really 2 ways. One is you can set a Bezier path, any Bezier path, and it will use that Bezier path as the outer edges of a boundary. Okay, it could be a rectangle, a circle, it could be a line, and just things that hit the line bounce off of it. Or you can you set this translates reference bounds into boundary, set that to true, and then the outer edges of the animator's reference view will be a boundary. Now you can't use that for your homework because of course the bottom one has to fall through. Okay, if your bouncing ball gets past the paddle, it falls off. So you'll have to use lines, Bezier curve that's line 2, line 2, line 2, or whatever. Okay? When you add a boundary, you give it an identifier. Now that identifier is an NS copying. So NS copying is a protocol that is implemented by NS string, NS number, things like that. So that means string and int and double also can be used as the identifier for a boundary. So when you hit a boundary, you get this message. You want to set yourself to be the UI collision behaviors delegate. And when a boundary is hit, it will send this message, well, it actually has a few other messages, to its delegate saying, oh, there was a collision between an item and a boundary, or between two items. And it's going to pass back that boundary identifier. You see that boundary identifier is the third argument there in this method that it's going to call in its delegate. And you have to cast that thing, because it'll be an NS copying, so you're going to cast it to be a string or a number, whatever you put in, cast it to be that back, okay? So that's a little small thing to understand, is that casting behavior. Okay? So that's simple collisions. The snap behavior is used a lot in UI. You won't be using this in your homework, but it's actually used a lot. It's essentially, you can imagine that you set up 4 springs on the corner of a view in a new location. The thing will fly to that space in the middle of the 4 springs, and then the springs will kind of oscillate. So snap behavior is basically move to here with a little bit of oscillation, okay? Kind of snapping, okay? But snapping in a way that doesn't disconcert the user, where things just like moving, it flies across the screen and then wiggles a little bit to let the user know, oh, there's a new thing just got positioned here. So you just specify the point you want it to snap to and the item you want it to snap, and it'll zoom over there. Okay, and you can control how much the springs spring, you know, is it a big movement or just kind of a small movement? You can control the damping with that property there, damping. Then there's a push behavior. A push behavior means push on this thing in a certain magnitude, you know, angle and magnitude, kind of like gravity. The big difference between push and gravity, 2 differences. One, a push can be a one-time push, right? Just instantaneous push. Or it can be a continuous push, which is not like gravity because it's not accelerating. It's just a continuous velocity. Okay, you understand the difference between acceleration and velocity? So push would be, if you had a continuous push, it would be a constant velocity. Okay? Now, one thing about the push behavior that's interesting is when you push, you add this behavior to your animator, it'll cause the items that are in it to be pushed, and then it just kind of sits around there wasted if it's not a continuous push, and it sits there wasting memory. And I'm going to talk about in a few slides how we can get that memory back. Okay, and we have to do a little memory cycle protection there. Now there's a special kind of behavior called a dynamic item behavior. Don't be confused about dynamic behavior, which is the superclass of all behaviors, and dynamic item behavior, which is a subclass of dynamic UI dynamic behavior. Item behavior says, how does this item, or any of the items added to this behavior, how do they behave when other behaviors make them interact? So this is when something smashes into a wall in a collider, in a collision behavior, how springy is it? Can it spin? Okay? Or does it have to stay unrotated? Those kind of things are all specified by this UI dynamic item behavior. So very often you'll have a gravity behavior, a collider behavior. You'll also have a dynamic item behavior that describes how much springiness is. It also does density, resistance, other things I haven't mentioned here. You can look at the documentation. But it's kind of all the things you would expect if you had a physics-based engine. You need to set the kind of attributes, the physical attributes of an item. This dynamic item behavior also can report to you the current linear velocity and angular velocity of this item. So at any time, if you want to know how fast is this thing moving and in what direction, you can get its linear velocity. Or if you want to know how fast is this thing spinning, if at all, you can get its angular velocity. And you can also add velocity to it in a certain direction. So if you had something that was moving and you wanted to stop it, you could. And then if you wanted to continue, you could add the velocity back. Just saying is all. Okay, so that's dynamic behavior. Now that's dynamic item behavior. Now here's UI dynamic behavior. This is the superclass of all of these behaviors. And it's kind of an interesting superclass because you can actually create a subclass, and in the implementation of the subclass, you add child behaviors. You add other behaviors. So you can kind of have a composite behavior. And this is very common to do. When you have 3 or 4 different behaviors all working on the same set of items, a lot of times you'll create a subclass of UI dynamic behavior, and in the init method, you'll call this method add child behavior, and you'll add a gravity, a collider, item behavior. You see what I mean? You'll add them as child behaviors. And now this behavior will do all the things that those behaviors did. Okay? So you have a kind of a big combined behavior. And I'll do that in the demo so you can see what that looks like. All behaviors know the dynamic animator they're in. And a behavior can only be in one dynamic animator at a time. So it has a property called dynamic animator, and it's read-only, and it will tell you, you can ask a collider, who's animating you right now, and it'll tell you the dynamic animator that is animating it. Also, all dynamic behaviors will be sent the message, will move to animator, when they're going to switch to a different animator. Especially this is switching from not having an animator to having one, or from having one to not having one anymore. Okay? That should be UI dynamic animator question mark. That's an optional. Okay? Because it might say will move to animator nil, which means you're being taken out of an animator. Okay, very important property on UI dynamic behavior called action. Action is a function, takes no arguments, returns nothing. 99.999% of the time it's set with a closure. Okay? And this piece of code will be executed every time this behavior acts upon its items. Okay? That means it's called a lot. Okay? Imagine a gravity behavior is constantly accelerating something. So it's constantly acting upon it. So it's constantly going to be calling this. So whatever code you put here in action wants to be really efficient. Okay? It wants to be very small, very compact. This is a place to do some optimization. Have a data structure where you can store things so you don't have to calculate things so much, because it's going to get called a lot. All right? And you want your animations to be smooth. You don't want them to be bogged down with something heavy going on every single time it interacts. Okay? One thing to be careful about this action method is that it is a property on the behavior. So if that action method's code refers to the behavior, you're going to have a memory cycle. And so you need to do that unowned thing, the capture list that we were talking about. You have to do that to break the memory cycle. This is a case where you've got a property on an object, and the implementation of the closure that you assign often refers back to the property, to the thing that the property is on. So be careful about that. Let me show you a quick demo about that in a slide or two. The UI dynamic animator, it also has a delegate, just like the collision behavior has a delegate. The animator has a delegate, and it'll tell you only 2 things. It'll tell you when the animation has reached stasis. In other words, none of the behaviors need to do anything. Okay? Nothing is happening in the animator. Everything is still. And then it'll tell you when that's changed. Okay? And now things are animating again. So every time it pauses, it'll tell you. And then every time it continues, it'll tell you. So that way you can tell what's going on. One thing you want to, when you design something that uses this stuff, is you want it to reach stasis. You don't ever want it to be just constantly animating, right? You want it to try and reach stasis if possible. Okay, now there might be cases where you actually are constantly animating, something's spinning and it's constantly spinning. Okay, but you want to design the system, unless that's really what you intend, you don't want things. A classic one is you have something with collision behaviors, the thing flies off screen outside of the collision area, and now it's flying off into outer space. And it's going to continue to animate forever as it flies billions of points away, okay? It's never going to stop. So you've got to be careful about that. When things go outside of the area that you're animating, they don't stop animating. You need to notice that and take that thing out of the behaviors so that they're no longer being accelerated off into nowhere or whatever. Okay? So be careful about that. That can happen in your assignment, of course, because the bouncing ball goes off the bottom. It'll just keep going, okay? Keep getting animated and never reach stasis unless you notice that and take the ball out of the view hierarchy probably and also away from the behaviors. By the way, don't ever put a view into a behavior, okay, when that view is not in the view hierarchy of the reference view of the animator. Obviously, the animator wants to animate the thing, and if it's not in its view hierarchy, like it's not in any view hierarchy or it's in a different one, the animator will basically crash your program and say, I tried to animate something, it's not in my view hierarchy anywhere. So don't do that. Also, don't animate things that are size 0, 0. Okay? It really doesn't make any sense to do that because it's not visible anyway, but don't do that. Animator doesn't like that either. All right, quick sample here of memory cycle avoidance. I was talking about the action method. So here I'm creating a push behavior. And I told you the push behavior, if it's instantaneous, it just sits around because the way you make a push happen is you create a push behavior and you add it to an animator. As soon as you add it, it's going to push any of its items. Okay? Well, after it's done, if it's an instantaneous push, not continuous, but instantaneous, well, it just sits there because it's been added to the animator, so it's just wasting space. So one way you can do this is in the push behavior's action, which I told you is called whenever the behavior acts on something. So after the push behavior acts and instantaneously pushes, well, you could just remove the thing from its animator. And I told you every behavior knows the animator it's in, so that's easy. You can just do that one line of code in the yellow there, push behavior, dynamic animator, remove behavior, push behavior, myself. Okay, but in that closure, I'm referring to myself, push behavior, because I'm removing myself. Okay, I'm also referring to myself because I'm getting my own dynamic animator. So this is bad. This is going to cause a memory cycle here because that action closure, right, it is going to stay in memory because the action property is pointing to it. And this push behavior is going to stay in memory because that closure is pointing to it. So since they're both pointing to each other, there's always going to be a pointer to them. They'll always stay in memory forever. And I mean forever and ever. Okay? No way to get rid of them. So how do we fix that? We put that unowned in there. So we put this capture list here, say that push behavior inside my closure is unowned, meaning don't capture it. I promise that it will be there when you want to use it, Mr. Closure says. You do not have to capture it and keep it in memory. Okay? And we know that's fine because obviously the action wouldn't even be called if the push behavior didn't exist. So this is good. This code's for sure going to work. Okay? You have to do this a lot with actions, and you'll probably have to do this in your assignment when you use an action. Okay? And I encourage you to try and make your push behavior do this as well. It's not a required task, but get your push behavior to clean itself up after it's done pushing. All right, so let's do this demo. Any questions about all that? Again, feel free to interrupt me. Coming up this week, Friday, we're going to learn about the parse framework, which is a way to basically store your data on the network. So if you're building some sort of final project or you want a back end or something, parse is really simple, nice asynchronous, using blocks. Closures, a way to do that. And the next week we're going to talk about a variety of topics. We're finally going to talk about modal segue a little bit and the application lifecycle and core motion, which is the gyro and accelerometer and that stuff. Okay? I believe we'll have just enough time for this demo. If I run a little long, you guys know what to do. So let's start here. Create a new project. Always use single view in this class. We'll call it drop it. Dropping some things. I'll put it in the place we always put it. Here we go. Now I'm going to clean up this stuff. Okay, I don't need this view controller. I'm going to have a custom view controller, but I'm not going to use the one. And I don't like the name of this. I'm not going to use this one. My storyboard right here, I'm going to, right off the bat, create a new subclass for my view controller. So it's going to be a UI view controller. I'm going to call it drop it view controller. Probably could have renamed that other thing. It's probably would have been just as good. So here's drop it. I'm going to get rid of all this right here. In my storyboard, let's set the class here to be drop it. The only UI that my drop is going to have is a custom view. And actually, I'm going to start out with a generic view. In your homework assignments, you might be able to get away, depending on how you architect things, with just a generic view here to contain your bricks and bouncing ball. So I'm going to have this. I'm going to make sure that my constraints are set here. So let's reset to suggested constraints. I always like to check them, make sure there's no magic numbers or anything. That all looks good to me. I'm going to create a outlet to this thing right here. So right there, I'm going to call that my game view. So this is just going to be the view that contains my little drop it game. It's not much of a game, but kind of a game. Right, so there we go. So what is my drop it going to do here? It is going to, along the top of my view, I'm going to drop little squares, okay, right along the top. So first, let's just get them dropped along the top, and then I'm going to add some gravity, and they're going to drop and fall. Okay, that's why they're called drops. They're going to fall down. So I'm going to put these drops along the top, and then later we'll add some gravity. So let's go ahead and do the putting them along the top first. Pretty straightforward to do. So I'm going to have the drops be evenly spaced along the top, and I'm going to have a public variable, or whatever you want to call it, called drops per row. It's just going to be an integer that says how many of these little squares go across the top. And so I'll do 10, but I can set it to whatever I want. I like my UI to be configurable. Of course, in your homework, you're going to want that because part of your homework is to add a settings panel that lets you set a lot of configurable things. So you want to design your code not to be hard-coded all the time. So here I'm just going to make this be a number that I can set. And that lets me have a drop size, okay, which is going to be the size of each drop. And I'm going to calculate that as well. I'm going to have it be a calculator property based on this drops per row. I'm going to have it be square, so we'll have the width and height be the same. And I'm going to make it equal to the game views bounds.size.width divided by the drops per row. So I'm just going to, take my width, available width of my view, and just divide it up evenly so that the drops exactly fill the space. And so now I can return a CG size that is both this width and this height. Okay, so now I know my drop size. I'm going to add a gesture, which is the tap gesture. When I put a tap gesture, I'm going to put one of these drops into my view. So let's do that. Let's go here to drag a drop gesture out here, tap gesture right here. Okay, so I'm going to drag this on here. I'm going to bring out my document outline. Here's my tap gesture right here. So I'm going to control drag. I'm going to call this gesture drop. It's a good name. That's what it does. It drops one of these things. Connect it. So here it is. I could put the code to do all the drop in here, but I'm actually going to put it in another method called drop, just because it's not necessarily something that could only be done by gesture. Maybe programmatically one could drop things as well. So I don't really want to put it inside that gesture. So all the gesture is going to do is do this drop. The drop just needs to figure out where the drop is. So let's get, actually let's make more space here first. This. Even more space than that. Okay, so we need to figure out where the drop is, so I'm going to make its frame, which is really easy. I'm just going to, first of all, create one that is at 0, 0. Use this nice CG point 0, by the way, which is 0, 0. And the size is, of course, our drop size. So now I've got a drop at 0, 0, and I'm going to move it along somewhere along there. So I'm going to move it to frame.origin.x equals cgfloat.random drops per row. And you're probably like, whoa, cgfloat.random? Well, you didn't tell me about that cool function. Well, that's because there's no such function. But I'm going to write that function right now. Really quick. There it is. Okay. So all it does is it just uses arc4random to create a random float between 0 and 1 less than this maximum. So here I'm going to get a random float between 0 and drops per row minus 1. Okay, that's cool. And then I'm going to multiply that times the drop size.width because I'm going to move it off. So I just took my drop. I've now made it over. It'd be in a certain spot. So I'm going to create my drop view. It's just going to be UI view. I'm going to use the frame initializer here. Use that frame I just created above. I'm going to set the drop view's background color to be UI color random. Another thing I added down here below. Okay, just picked a random one of 5 random colors there. Something I wrote. Notice, by the way, that when I added these extensions to UI float and UI color, I made them private. That means only I can use them. Okay? But it also means the name won't conflict with someone else. If someone else writes their own cgfloat.random that takes an int, theirs will work in their file and mine will work in my file. Okay? So it's private to this file. So that's one nice thing about extensions. You can kind of control the privacy of extensions. So there I have my drop view. Now I'm just going to add it to my game view, add subview. We really haven't had you doing add subview, because you've been doing all the views in your storyboard. But in your homework, you're going to be adding your bricks, views, and all that stuff using add subview. Probably your storyboard is going to be completely blank, or maybe it might have the score and some other things in there, but the bricks and the paddle on the ball, that's all going to be added. You're going to add with add subview. That's part of what this assignment is about, so you get some experience adding views, creating and adding views in code. Okay, so that's what we're doing. So let's go see what this looks like. Hopefully when we tap, we'll get a random square along the top of our view here. So tap, oh, we got one. Oh, good, we're getting them. So here I'm tapping them. This is great. Okay, so we're adding these things along the top. Now I'm going to add gravity. Okay, I'm going to add a gravitational field, and it's going to apply to all these things. It's going to pull them all down to the bottom of the screen. Okay, so these all will just fall down. Turns out this is very, very easy to do. Okay, all I need to do is create a gravitational field. So I'm going to say let gravity equal a UI gravity behavior. Okay. So boom, I have a UI gravity behavior. I'm going to take the default magnitude and direction, which is down at 1,000 points per second. So that's perfectly fine to me. Of course, I also need a dynamic animator. Okay, so I'm going to create a dynamic animator here. Now I want to say this. Reference view is game view. Okay, but I'm not going to be able to do this. Now a lot of you tripped into this on your assignments. I saw on Piazza a lot of questions about this. You're like, oh, what's going on here? And you click this warning and it says, game view is not a part of drop it view controller. Of course it is. It's right here. What the heck is going on? And hopefully all of you have figured out that the reason that's happening is because I'm in the middle of initializing here. Okay, this is initializing this variable, and you cannot access your own properties and methods until you're fully initialized. So obviously you can't access them while you're initializing by definition. So that's the problem. So how do I get out of this conundrum? Because UI Dynamic Animator needs this game view as its reference. Well, one thing is I could make this an optional and set it to nil, and then in viewDidLoad, when I know that's set, I could create the animator there. Yeah, you could do that. Another way to do it is using a lazy variable. So I'm going to make this var lazy, and I'm going to set its initial value equal to the result of executing a closure. Okay? So this is not going to happen. This is not going to get initialized until someone actually asks for this animator. And once they ask for it, I'm going to execute this closure by just having the closure with parentheses. It takes no arguments, so I just call it with parentheses. And it's going to execute this closure. Now this closure better return a UI dynamic animator, okay, because I'm setting it equal to the result. And in fact, it's going to, because I'm going to say let lazily created dynamic animator equal that. Okay. Now this is inside a closure, so I'm going to want to say self.gameView, right? And then I'm just going to return lazily created dynamic animator. Okay? Now, one thing, this kind of solves the problem. Okay? I don't have any warnings, but you got to be careful. You better not call this before this gets set, because this is going to be nil. You're going to have a reference view nil. Your animator is going to get created with no reference view. It ain't going to work. Okay? So you got to be careful about when you call this. Okay? When you access this property. So I'm not going to access this property until I get to viewDidLoad, because then I'll know that this outlet right here has been set. Okay? So let's go ahead and do viewDidLoad, in fact. So in viewDidLoad, all I'm going to do is say animator add behavior gravity. So now I have a gravitational field. I've added it to an animator, so an animator is now going to be animating the behavior of items in there. The only thing I need to do is say which items are affected by gravity. So I'm going to go right down here and say gravity, add item, my drop view. Now, the instant I say this, the instant the behavior gets added to the animator, all items in that gravity field are going to start animating. Now, I can add those items later, and then they'll start animating. I can take them out, and they'll stop animating. It's all instantaneous. Okay? So if I run now, since I have an animator and a gravitational field, and I put the items in there, they fall. Okay? Now they're accelerating. See how they're getting faster and faster at the bottom? They're accelerating due to gravity. And I can have as many of them as I want. Okay? And they will accelerate. They'll all be accelerating independent, their own gravitational acceleration. Okay, now this is great, except for they're just falling off the end and they're gone. And really what I want is for them to stay on screen. So I'm going to create a collision behavior where the edges of my reference view here are going to stop these things, and they're going to bounce off. Okay? So you're going to collide. Again, really easy to do. I'm just going to go up here and create a collision behavior. I'm going to do the same thing here and do a lazy version of this, and I'll show you why I'm doing that. I'm going to call it my collider. It's a UI collision behavior. I'm going to set it equal to executing a closure. I'll say let my lazily created collider equal UI collision behavior. Okay? And then, oops, don't want that there because I'm not creating it there. There we go. So now, the reason I did this is not because I have this reference view problem or anything like that. It's just that I want to configure this thing. Okay? And one thing I want to configure here is that I want it to translate the reference bounds into a boundary. That means the edges of my reference view are going to be a boundary. So any items that are in this collider will bounce off of those bounds. Okay? And then I'll return. So here you can see two different reasons that I've used for using this lazy with the closure. One is there was something I couldn't access, okay, during initialization. Another one is I wanted to initialize some state. Okay, those are both valid reasons to do this lazy business. Okay, so I need to add that to the animator, collider, and of course I need, if I want these drops to collide, they need to be added to the collider as well. Okay? And that's it. That's all. Again, this stuff is amazingly simple. You just add the behaviors and things will start behaving. Okay? So let's watch what happens here. So we drop one in. Oh, see? Bounce on the bottom. Didn't bounce very much. Not a very big bounce. But it did bounce. We're going to make it bounce some more in a minute here. But again, if I send a whole bunch of them down, not only do they bounce off the bottom, they'll bounce off each other a little bit too. And they also can rotate. So if I send too many of them down here, if they're getting a little, look, oh no. Okay, so these, oh no, it collapsed. Okay, so these things are allowed to tilt and rotate, and they can all just collapse and fall down. Okay, because that's the physics of them. When they bounce, they might hit a little edge, and boom, since they can rotate, they'll tilt and tip over. Okay. All right, so that's that. Now, what if I had my game here and I wanted to not have them tilt like that? I wanted them to stay in their nice, neat rows. And also, I want them to bounce more. I don't want such a little tiny bounce. That's not very exciting. I want a big old bounce, okay, off each other and off the bottom. So how would I do that? Well, I would add a dynamic item behavior that we talked about in lecture. But it's starting to get to the point here where I have an awful lot of different behaviors acting on each of these drops. So this is the time where I'm probably like, I want to create my own dynamic behavior that is a composite of all these things. The collider, the gravity, and then the bounciness, and the don't rotate, all that. So I want it all kind of in one thing. So let's do that. We'll just do that by creating a new file here. New file. And it's a Cocoa Touch class. It's going to be a UI dynamic behavior subclass. Okay? I'm going to call it drop it behavior because that's what it is. It's the behavior for these drop it things. So I'll call it drop behavior. I could maybe call it drop behavior. I like drop it behavior because it's really the behavior of my whole, all the things participating in my drop it game here. So here's a drop it behavior. Doesn't have anything in it to start. And all I'm going to do is basically take these things like gravity and collider out of here, okay, and put them over in here, like that. And then, and then I'm going to override init from UI dynamic behavior, right? This is a subclass of UI dynamic behavior, so I'll call super init. And then all I'm going to do is add child behaviors for gravity and add a child behavior for the collider. Okay, so now that I've added these behaviors, now my drop it behavior behaves like those things do combined. Okay, because they're children behavior of me. So this is an awesome way to create a powerful behavior just by taking other powerful behaviors. I'm also going to have an add drop function here that takes a drop, which is going to be a UI view, one of these things that we're creating, and I'm going to add the drop as items to both my gravity and my collider. And in fact, and this is debatable whether this is kind of the architecture one would want, but I'm going to actually manage the view, whether it's in the view hierarchy or not here. So I'm going to add this drop to my reference view whenever you call add drop in my behavior. So I know the dynamic animator I'm in, right, because I'm a behavior. I might be nil, but might not. And I know the reference view for that dynamic animator. That might be nil or probably not. And so from there, I can add subview this drop. So if you call add drop on this drop behavior, it will add it to the reference view and then add it to its behaviors. And same thing, I could have a remove drop, right, which takes a UI view, and it does the opposite. So gravity, remove item, the drop, collider, remove item, the drop, and drop, remove from super view. Okay? So now I have this nice class right here, which is a behavior, and it replaces all those behavioral things over here. So instead of animating behavior and gravity separately, I can just create a drop it behavior equals drop it behavior. Okay, so just create one of those, and it could even, I'd probably even say let here. Okay, and then in add behavior, I can just say add the drop it behavior. Okay, so I don't need to add the collider separately, I just do the drop behavior. And same thing down here. All three of these things, adding the subview, those all are just replaced by saying drop it behavior, add drop, the drop view. Okay? So you can see my code here has gotten much more focused on kind of what we're doing, and the behaviors have been moved off into the behavior code. Now let's run this to make sure we didn't break anything by doing that, and it looks like we're in good shape. Okay? But these things can still tilt. They're still, you know, getting out of their little columns, and they're also not bouncing very much. So let's get back to fixing that. And now, whenever I want to add a new behavior, I'm going to add it in this behavior class. So what kind of behavior is that? I'm going to do lazy var again here. I'm going to call it my drop behavior. It's a UI dynamic item behavior. Okay? I'm going to do the same magical trick. Not that magical. And I'm going to say let a lazily created drop behavior. I'm just using this name to really make it clear to you what's happening here. It's a UI dynamic item behavior. And I'm doing this again because I want to configure it, just like I did for the collider. And so let's do it so that the things can't rotate. So one of the things you can do is allows rotation, false. Okay? Another thing you can do is the bounciness, which is the elasticity. So I'm going to set the elasticity to about 0.75. Elasticity of 1.0 is perfect elasticity. So a thing bounces off something, it will have the same amount of energy coming off as it had coming in. Okay? Perfect. So 0.7, these things will eventually settle down. Okay? So there's that. We'll return our lazily created drop behavior here. And so all we need to do to make that work, again, is add it as a child behavior here. Oops. Drop behavior. And also make sure that we add any drops to it as well. Drop behavior, add item, the drop. And same thing down here. Drop behavior, remove item, the drop. Okay? So we don't have to change anything in the other place. Okay? Back over here, we need to change nothing because we're only changing behaviors here. So this code has delegated all its behavior off to the drop behavior. That question?
Yeah, I think I'm a bit confused. How come like we can, I guess, like use the lazy variables in our init if they're not created until init is like finished, you know?
Well, so the question is, how can I do this, basically? How am I allowed, during initialization, to not have this set? Well, and the answer is, it's a feature of the language. It will suspend the rule that says that all things must be initialized as long as you've set it to something that can be determined later. So lazy variables, if they're marked lazy, they don't have to be initialized at init time. That's what lazy means. It does not have to be initialized at init time. But the first time someone accesses it, it's going to be initialized. Even if it wasn't a closure, even if we set it to be equal to something else, that would happen at the time someone accesses it. That's going to have to be, by definition, after the full initialization, because no one can access any properties until full initialization. Make sense? Okay? If you have more questions, I can cover it more, but that's the basic deal on the lazies. Yeah?
So previously, while there were some small gaps, I think you set the size of the rectangle to be strictly equal to the size of the whole content divided by like the number or something. While there something.
There were no gaps along top. It was only when they started falling and tilting a little that they made gaps between each other. Watch. Okay? So here, look how much springier now we are. And also notice they can't tilt, so they stay in their columns. You're going to see there's no gaps now. Okay? It was only the tilting that was causing them to have gaps. So you can send these things down. They're bouncing off each other and also off the bottom. Okay? And they eventually settle into stasis. Okay? Everybody got that? All right, the next thing we're going to do in our fun game is we're going to do a Tetris-like thing, which is when a row is fully clear. Question? Yeah?
Why are all the boxes completely aligned horizontally?
Why are they completely aligned horizontally?
Well, they're not. Like some of them are a little higher.
Oh, yeah, why are there slight differences? Well, I'm not 100% sure of why that is, but I think it's because, and don't quote me on this 100%, but I think it's because when the thing is animating, it's not animating on integer boundaries, okay? And I think the things can slightly overlap by tiny fractions, but it's enough for one or more to draw slightly 1 pixel or point off. Does that make sense? But that's a good question. I've noticed that as well. And it's like right in here, see those guys right there? Slightly different. So yeah, good question there. All right, back to where we were here. So what I want to do is remove a whole row when a row is complete and when my animation settles down. Okay, when my animation stops, pauses, and a whole row is full, I want to remove it. Okay, so how am I going to do that? Well, I have a nice function called remove completed row, which I'm going to type in really fast. Again, here it is. Don't worry about this. You can look at this after lecture. It's not doing anything except for looking for rows that are full. And when it finds a row that's full, it goes through and calls remove drop, right, in my dropping behavior on all of the things in the row. That's all it does. Okay? All this is just finding the ones that are all in a row, that complete a row or mostly complete a row. It allows a little bit of gaps in there. And then this just removes it. It only removes one row, though. Starts at the bottom. Starts going up until it finds a row and removes it. So it only does one. All right? Now, how do we get this remove completed row called? Okay? Well, I'm going to call it when the animation settles down. And I told you that I can find that out using my dynamic animators delegate. So here's my dynamic animator right here being created. I'm actually just right here going to say, make my dynamic animators delegate be myself. Okay? And of course, we know that's going to cause an error right here, and that error is you don't implement the UI dynamic animator delegate protocol. So, okay, no problem. UI dynamic animator delegate. Okay? Problem solved. There's only 2 methods in that protocol. They're both optional. You don't have to implement them. The one we want is dynamic animator did pause. See, here's the 2 methods. We want this one, did pause. So when it pauses, in other words, it's reached stasis, for now anyway, it's going to pause. And when it pauses, I'm going to remove completed row. That's it. Nothing else required. So let's see if that works. All right, so put a bunch of drops down here. Now, if it comes to stasis, but there's no completed row, which there isn't because there's gaps in this row, it does nothing. But if I throw some more down here, enough that it completes a row, which this is going to complete a row, Okay, once it settles and pauses, then it will remove the drops and the other ones will fall. Okay? Now, the two things to notice here. One, it waited till we paused. That was cool. Two, after it removed them, everything else started animating again because nothing was underneath them anymore. So gravity kept pulling them down and they fell. Okay? I didn't do anything to say keep going. It's just as soon as the gravity could work on those things, they started working. Okay? It's important to notice the animator, even if it's paused, it's always waiting for a behavior to do something. Okay? So that's cool. And this happens, and if I have multiple rows, let's just make it so there's a whole bunch of rows that are complete. And you'll see that it will remove a row, and then it'll pause again, and it'll remove another row. Okay? Okay? And, depending on how many things are stacked up and how it does, you'll have a different response to it. Okay? Now, let's go back and make it so they can rotate. And let's see what happens again. So how can we make it rotate? Trivial. We just go back to here and just turn this allows rotation back to true, which is the default. Okay? And run again. Okay? So let's put a bunch of them down here again. Now they're going to start banging into the edges of each other, and they'll start rotating and bouncing around all over the place. Right? But they're still filling up rows. Okay? Okay, see, they kind of bounce around. There we go. Okay, too big a gap on that last one. And if I put more down here, I'll get it again. Okay? Everybody cool with that? Understand what's going on there with that pausing business and the fact that the animator is always trying to continue animating? Okay? All right. The next thing, I think we have time for both of these things. The next thing we're going to do is let's talk about this collider a little more. Right now, the collider is only colliding with each other and colliding with the walls. What if I want to put something right, like I'm going to put a circle right in the center of my view and have the things hit that and bounce off. So how do I create an arbitrary boundary, basically? Well, the boundaries are created using Bezier paths, as I said. And you can create a boundary. It doesn't have to have any graphical representation. So in fact, I'm going to start by doing that. So I'm going to go to my drop-it behavior right here. And I'm going to make public a method. I'm going to create a public method to add a boundary. Okay? So I'm going to call it add barrier, actually, because it's going to add a barrier somewhere, a barrier to these things coming down or whatever. I'm going to call this, these things need to be named. Remember I told you about the barrier or the boundaries. They have like an integer or a string or whatever. So I'm going to use a string to name these things. So I'm going to pass in a Bezier path, and I'm going to name it. So I'm going to have an argument called name. Okay, and I'm just going to call the colliders things in here. I'm going to remove any old boundary with that name, and then I'm just going to add a new boundary, okay, with that name and that path. So that's all I'm doing. I'm just kind of making a nice simple method here that removes the old one and adds the new one. So there's only going to be one barrier with that name, and I can move it any time by just saying add barrier. Okay, so add barrier removes the old version of it. So that's add barrier, and so we can put that barrier in there invisibly. Let's put it maybe in our view did layout subviews. So every time we change our bounds, we'll move this barrier to the very center of that. So I'm going to override view did layout subviews here. Super.view did layout subviews. I want it right in the center. So I'm going to, well, let's have the size of it be, how about the same size as a drop? Just to be simple. Okay, I'm going to have this barrier that I'm going to put in the middle be the same size as a drop. I'm going to have the origin of it be like this. Let's put it in the middle. So that's a game view bounds mid x minus the barrier's size. Barrier size dot, oops, barrier size dot width divided by 2. And then the game views bounds mid y minus the barrier's size dot height divided by 2. So I'm just putting it in the middle. Okay. So let's let this UI Bezier path that we're going to create just be UI Bezier path. We'll make it a circle using oval in rect. Okay, and we'll make a CG rect, which is the barrier origin and the barrier size. Okay, so everyone understand I've created a Bezier path that's a circle right in the middle that's the same size as a drop. Okay, and then I'm just going to tell my drop it behavior, add this barrier, and we'll call this barrier, let's be good coders again and say struct. We'll call these path names, static, let, we'll call this one middle barrier or something. This is going to be the string we use. So here we'll go path name dot middle barrier. Okay? So I can add this barrier right here, and that's all I need to do. Once you add the barrier, the collider is already colliding, so it's going to make things collide with it. So let's see what this looks like. Okay? See if we can tell. Oh, do you see things bouncing away from the middle there? See that? Okay? But it's a little bit bad because we can't see it. I'd like to see this barrier, but that's an independent thing. Seeing it versus it being there is different. So to see it, I'm actually going to make my background view right here, instead of being a generic UI view, I'm going to make it be a view that can draw Bezier paths. Okay? Now, this is surprisingly simple to do. Okay? I'm just going to create a UI view, subclass, UI view. I'm going to call it Bezier paths view. And it's going to basically draw as many Bezier paths as you want. They'll also be named, just like the boundaries are named. Okay, and I'm going to do this by saying var Bezier paths. These are my Bezier paths that I'm going to have. It's just going to be a dictionary with strings as the keys and UI Bezier paths as the arguments. Okay. By the way, I haven't been doing private in the demo for expediency, but again, private is important. Here I am going to do the right privacy. So now I'm going to have a function called, what did I call it? Add path or something like that? Yeah, set path. Set path, and it's going to take a path, which is a UI Bezier path. It's going to be optional because we're going to allow you to clear out paths if you want. And then it's also going to let them be named. And I'm just going to put it in that dictionary. I'm just going to say Bezier paths, paths sub name equals the path. And of course, I just changed my model basically, so I'm going to do set needs display. Okay? Then to draw this, for underbar path in my Bezier paths, path stroke. Okay, that's it. This is in the entire implementation of this view. Okay, so it's just going to stroke them in black. We could add colors, all that stuff, but we're just going to stroke them all in black. This is enumeration of a dictionary. Hopefully you recognize that. I don't care what the name is here while I'm doing this. I only care the name because I want to keep them unique is all. Okay, so now what I'm going to do is go back to my storyboard, and instead of this being a generic view, I'm going to go to the identity inspector and turn it into a Bezier paths view. And also in my drop it controller over here, I'm going to change this outlet from being a generic UI view to being a Bezier paths view. So now the view that I'm doing all this animation in can draw arbitrary Bezier paths. Okay, very convenient because I'm going to have it draw that circle. Okay, that circle that we're having the collider do, which is right here. And I can do that with one line of code. I'm just going to say game view, add path or set path, the same path, and I'll use even the same name, path names dot middle barrier. Okay? The good thing now is every time view did layout subviews is called, it'll replace, it'll move it to the middle and redraw it. Okay, so let's now take a look at this. There it is. Now we can see it. It's still a barrier like it was before. So something hit it. Come on. There we go. Boom. Okay? And it's a complete barrier, and it actually is along that Bezier path. It's not, the square containing it. It is actually on it. So if I fill up this thing all the way where it starts getting to that, you'll start seeing them tip right up against. You see how they pile right up against it there? Okay? So you can have an arbitrary Bezier path there. Okay? And if I rotate, okay, it'll put it in the middle. Okay? Zoomed it out a little bit, but some of the things fell off the edge when I rotated there. Got to be careful of that in your game too. When you rotate, if your bouncing ball is not in the middle area, then it's going to be outside the boundary. And so it's going to fly off into outer space forever. Okay? Okay, so that's how we do barriers. And you're going to have your bricks are going to be probably not round. Well, they could be round if you want. And you could put as many of these little barriers as you want up here. Okay? And when you hit one of these, that delegate method, you're going to set yourself as a collision delegate. I don't really have time to do that. You know, you could make it do something, flash or animate, whatever is required by the required tasks. Okay, the last kind of behavior I'm going to show you is an attachment behavior. So the way I'm going to do this attachment, actually let me show you here, is when a drop comes down, I'm going to be able to grab onto it, okay, with like a piece of string, okay, or more like a metal rod. Grab onto it and I can move it around, okay, swing it around in a circle and let it fly if I want. Okay, so that's what I'm going to do. So I'm going to do that with an attachment behavior. I'm just going to create an attachment from where I start my pan to the middle of the drop, the currently dropping drop, or the last dropped drop basically. And then as I pan around, I'm just going to move the anchor point. And because animation is all happening instantaneously, it's just going to all magically animate to adapt to the fact that I'm moving the anchor point of this attachment. Okay? And all the other behaviors are still going to work on it. The gravity, the collisions, all still going to work on that thing. The attachment is just going to be another behavior. Now I'm going to put this attachment in the controller right here instead of in the behavior, just so you can see it all happening a little better. So let's do this kind of in multiple steps here. Let's go ahead and do the gesture first. Okay? So to do the behavior, I need an attachment behavior. So I'm going to create an attachment behavior here, UI attachment behavior. Now this one's going to be an optional because I only have this attachment when I'm panning. Okay? I don't have this attached. It's nil, basically, if I'm not currently attached to something and panning around. Whereas the dropped behavior is happening all the time. Okay? Again, I could put this attachment behavior in the dropped behavior. I could do that. I'm not going to for kind of seeing it on screen, the code on screen issue, but I could put it over there. So I'm going to put it here. So I have this attachment. We're going to have to do some things with this attachment in a second, but let's just say we have this attachment. Let's go add that pan gesture. Okay, so we'll go over here. We'll go to our storyboard. Here's our storyboard right here. Let's go down and find pan. Where is it? Pan, pan, right here. So let's add pan to this thing. Here's pan in the document outline. Let's go ahead and put the pan gesture down here by the drop gesture, I guess. Okay, put it right there. Okay, it's an action. We'll call it grab drop. Okay, because that's what it's going to do. It's going to grab onto a drop. Okay, here it is. All right, that's all we need to do in our UI here. Let's go back to our drop it controller. All right, so how are we going to implement this grab drop? All right, we have that attachment. Basically, all we need to do is when we first start our gesture, we need to create that attachment. Then as it moves, we're just going to move the anchor point. And when it ends, we're going to set the attachment back to nil. So this is incredibly easy to do. You're finding all of this, I hope, to be pretty straightforward to do. It's a pretty amazingly powerful system. But here in this pan gesture, first I'm going to get the point, okay, the gesture point. That is just the sender's location in our game view. Oops, game view. All right, so now I know where that pan is. And I'm just going to switch on what state we're in with this gesture. And if we're in began, so if the thing just began, then I'm just going to create the attachment. So I'm going to say attachment equals UI attachment behavior. Now, here's all the ways you can attach things. You can attach between two items, between an item and an anchor. You can even attach between two items or an anchor with the offset from the center, which is kind of a fun one because if it can rotate, then as it spins around, it'll be spinning around because the attachment's not dead in the center, right? It's right off the side. It's not in the middle of the square. It might be in the corner, and so it kind of rotates. So that's kind of fun. But we're just going to do to the center here. So we need to attach the item. So we want this one right here to the anchor. This is the one we want. So the item, what item are we attaching to? Well, we're attaching to the last dropped view. So I'm going to have to create a last dropped view, which we'll have to go implement. And what anchor? Well, I'm going to anchor it to the gesture point, okay, wherever that pan gesture is. So let's do this last drop view. That's easy. We'll just say var last dropped view. It's a UI view that can be nil if we're not currently dropping. And then down here in drop, where we drop something, I'm just going to say that the last drop view equals the drop view. Okay, so I'm just keeping track of the last drop view. Okay? That make sense? Exclamation point, yeah. No, we don't want that. We want to say, Actually, I guess we'll always have a last drop view. This is a kind of one where it's like, do I want to if let there, or do I just want to do it? Actually, I'm going to if let. I just want to be careful here in case for some reason the last drop view is not around. So I'm going to say if we can let the view to attach to equal the last drop view, then we will start this attachment business. Okay? Be safe there because we might change something in the future where we don't always set the last drop view to something, so I want to be careful there. So we have the attachment. By the way, I'm also going to put a feature in my game that once you grab onto something, you can't grab onto it again. Like if you grab onto it and let it go, I'm not going to let you grab onto it again because I might want to eventually turn this into a game where you have to like line the things up into perfect stacks or something like that. And so I could put something in here like this to make my game a little more challenging, where I can't constantly be just re-grabbing it until I get it exactly where I want. Okay? So that's it. All I have to do in began is create that attachment, and then if things change, all I have to do is change that anchor point. That's the attachment's anchor point. And if the attachment is nil, this will just do nothing. That's fine. So that's the gesture point. And when it's all over, okay, the span is just, I'm just going to say attachment equals nil. Okay? All done. So and of course we have the default case, all the things like the pan failed or whatever. I'm just going to do nothing in that case. That's probably not actually. I probably should be doing something here. If I was in the middle of this and a phone call came in and my pan failed, I probably should be doing attachment equals nil. Okay, so probably attachment equals nil should be the default case. But I haven't really analyzed that. I haven't done that full design, but that's something you obviously would want to think about if you're building something. Okay, now this attachment, we're creating it, but notice we never add it to the dynamic animator. So this attachment is not ever actually going to be animated. So where are we going to do that? I'm actually going to do that in the will set and did set of the attachment. So in the will set, okay, this attachment is about to be set to something new. I'm going to tell my animator to remove the existing attachment. So if there's an attachment behavior that's existing right now, remove it. And similarly, as long as I am setting this to non-nil, if the attachment is not nil. Okay, so if the attachment is not nil, then my animator can add the behavior, the attachment. Okay, it's getting pretty bad. Okay, got it? Sorry about that. So you get that, what I'm doing there? I'm basically adding and removing from the animator as the attachment is set or not set. Now, we could go ahead and run this now, and I'm going to. We're not going to be able to see it, though, because we're not setting any Bezier path in our view. But let's go ahead and look at it, see what it looks like. Okay, so here's the drop. I grabbed it. Okay, so if you can kind of imagine, I can even like balance it on its little stick. So you can see, imagine there. And if I let it go, or I can bounce it off this thing. Okay, it's still attached. Right, see that? Boom. And I can let it go, and it'll bounce. Okay, I can grab the next one. Boom. Now, it would be nicer if we could see this little attachment wire that's on here, right? And we can because we have this nice view that makes it easy to show a path. So really what we need to do is we just need to say let path equal UI Bezier path. And then we just need to say game view, add path, this path, which we're going to have to create. And then again, we need a name for it. So we'll call this the attachment path name. Attachment, like that. Okay, so path names dot attachment. Okay, so really all we need to do is create that path in here. Okay, that path between the attachment point and the set path. Okay, we just need to create this path that goes from the attachment anchor point to the middle of the view. Well, okay, we need to find that view. So how do we get the view? All behaviors, most of them anyway, can tell you the items that they're currently animating, all right, that they're affecting the behavior of, and attachment behaviors can do that. So I'm going to say if the attached view equals, and how am I going to get it? I'm going to get it by asking the attachment for its items. That's all the things that it is attaching. Could be 2 items, could be 1 item. In our case, it could be 1. Since it's 1, I'm just going to get the first one. First is a array method, okay? And I'm going to make sure that it's a UI view. It's going to be a UI view. but I'm going to make sure it's a view I view, so I'm going to do if let here. Okay? So now I know that I've got the attached view that's going on. It's in here. So now I can make a connection between these two things. I can just say path, move to point. I'll move to the anchor point. So that's the attachment's anchor point. And then I'm going to path add line to. And I'm just going to add a line to the attached views center. Okay? So we got that. The only thing about this is only going to work once when did set happens of the attachment. When I first create that thing, it's going to draw that line. That's great, but what as I'm moving it around? Okay, when I move it around, the anchor point moves, so this is going to be no good anymore. So I actually have to put this code inside of the attachment's action. Okay? So the action is just closure. Once we put it inside a closure, we're going to have to do self dots in here so we can be obvious that we are capturing self when we do this. Here's another self dot that we need, and there's another self dot, and this we'll say question mark. Okay. So here we have this action. So this is good, but and this will work. Let's go ahead and run this. Okay, so grab a dot so you can see it works. Right, it's showing the connection there, but it doesn't clean up. That's no good. Okay, and so what's going on here? Okay, let's fix two problems. One, this cleanup is no good. That's just because in will set right here, we need to tell our game view to set that path to nil for that name, the path name attachment, right? Every time we set a new one, we need to delete the old one. The other thing is we got the memory cycle problem here, right? Because this attachment, which self points to, so self points to attachment, attachment has the action points back to self. In fact, okay, you're just using it here, the attachment itself, but it's pointing back to self. So we got a memory cycle here. So we have to say that inside here, self should be unowned in this closure. Okay? And that means that the system will not keep self in memory in order to make this closure work. It will assume the self is always going to be there, which it is always going to be, because if there's no self, there's no attachment. If there's no attachment, there's no action, so then there's no closure. Okay? So we broke that memory cycle here. All right, so that fixes both of these problems. So here we go, drop one, swing it around, bang it on here. Oops, like that. Let go. Okay, put a whole bunch of these down here. Okay, now notice that, let's say I have enough of these things to make a row disappear. But if I drag onto this and I'm animating, see the row won't disappear because we're never coming to stasis here. Okay? But if I let it come to stasis, then we don't have a complete row. Okay, let's get a complete row. There we go, I think that one. Okay, so now we got a complete row there, the third one up from the bottom. And as long as we do this, it's not going to come to stasis, it's not going to pause, it's not going to do it. But if we let it go, it settles down, now it'll do it. Okay? All right. So that's it for that demo. I got to show you a lot of different behaviors there. I didn't show you push behavior, which you're going to need for your assignment. I didn't show you snap behavior, which is very commonly used in the UI, but you don't need it for your assignment, so I didn't show that one. But I showed you the collider and the gravity. The gravity is an optional one in your assignment. You might want to use gravity. It could be fun. Totally up to you. But that is it. So good luck with assignment 5. And if you have any questions, I'll be here as usual.
For more, please visit us at stanford.edu.